So we saw in the last notebook that medspaCy, while great for general purpose English, has some limitations when working with clinical text. So there are a few big differences between clinical and normal English. So first of all, clinical text is really messy, with lots of kind of semi-structured formatting from the electronic health record, a lot of abbreviations for diseases or medications, and some of these are ambiguous, meaning they can mean different things. And there's specific tasks that you need to do in clinical NLP, and we're going to go through some of these tasks in these notebooks. So one thing that really makes medspaCy great, and one of the reasons that I work with it so much, is that it's really customizable. So while it gives you a lot of default functionality and default models, you can create your own components or add attributes to the data in medspaCy. And so developers and researchers can do a lot of extra work to add medspaCy extensions. So here are a couple examples of medspaCy extensions for medical or medical-like problems. And the one that we're going to be using is called medspaCy. So there's a link to medspaCy here, which if you want to see the documentation and information about it, you can find it here. And this is a project that I'm heavily involved with, myself and some collaborators at the University of Utah and the VA. And the goal of medspaCy is to provide flexible and easy-to-use medspaCy components for common clinical NLP tasks. And we're going to go through a few of these today. Oops. So let's see, make sure you run your cells. And here's the medspaCy logo, which one of my colleagues made and I think is pretty cool. Okay, so to get started with medspaCy, it looks pretty similar to medspaCy. So we're going to start by loading a model using medspaCy.load and save that as NLP. So just like before, where we loaded this default model using medspaCy, this model consists of a series of pipeline components. So whereas before we saw that there was a tagger, a parser, and an NER, now we have a sententizer, a target matcher, and context. So what do each of these do? Well, the sententizer we're not going to worry about too much, but it splits up a clinical document into individual sentences. Like I said, clinical texts are very messy, so this isn't really an easy task. The target matcher we're going to see in this notebook, where you can use rule-based extraction for identifying medical concepts. And context, we don't need to worry about in this notebook, but we'll look at extensively in a future notebook. So for now, we're going to take this out of our pipeline. Okay, so in the first notebook, we looked at this text and saw that medspaCy really didn't know what to do with it. So if we want to extract information from this text here, what concepts would we be looking for? So I would say that some useful concepts are problems, treatments, and tests. So these are very relevant and common clinical NLP tasks. So looking at this text, what examples of these concepts can you find? So think about that because we're going to start extracting them in the next cells. So we're going to start by building a rule-based system. So as you saw in the lecture, the two main paradigms of NLP are rule-based and statistical or machine learning. And in a rule-based, we manually define patterns to match concepts in the task. So there are a few ways to do this in medspaCy, and medspaCy gives this class called the target matcher, which will extract concepts using target rules which define what you're looking for. So we're going to focus on this target rule class. So we pass in two arguments to this class. So the first is the literal, which is a span of text that you want to match in the text, and it's case insensitive. And the second is the category, which is the label that you're going to assign to the extracted concepts. So given this text, we're going to start by extracting two examples of conditions, or problems. You can also call them problems. I'm actually going to change this because this was supposed to be... Okay, so we're going to define two target rules here. So the first is hypotension. So hypotension is low blood pressure, and that can be considered a clinical problem. And the second one is CKD stage 3. So we create these rules, and then we add them to our target matcher by using this .add method. Now we're going to process our doc, and we can look at the entities that it extracts, and now we have hypotension and CKD stage 3. So medspaCy gives some visualization capabilities, and so there's this function called visualizeEnt, which is similar to what we saw before, where it highlights the spans and the labels in the text. Okay, so this is a start, but you can see that there's still other text that we want to extract over here. And the first one that we're going to look at is chronic kidney disease. So we already extracted one example of CKD, CKD stage 3, but here you can see another example of CKD stage 2. So chronic kidney disease can happen in 5 different stages, and it's kind of a pain to write through, to write examples of each one. So CKD stage 1, 2, 3, etc. So what we're going to do instead is we're going to write a more advanced pattern that will extract any of these. So the way that medspaCy allows you to do this is using something called pattern matching, where you create these dictionaries that tell you attributes about the tokens. So we're going to create a list where each attribute, where each element is a dictionary telling us something about the token. So this is a little confusing unless you see an example. So let's think about the phrase CKD stage 2 and CKD stage 3. What is common between them, and so what can we extract using that? So in both of them, the first token, or the first word, is CKD. Oops. So we first want to extract any token where the lowercase is CKD. The second is stage. And then the third one, this is where it gets a little interesting. So it could be 1, 2, 3, 4, or 5. So we're going to simplify this by saying that it's like num, like a number. So this is medspaCy syntax, and we're not going to go through it in too much detail, but you can go to medspaCy and look for more examples if you're interested. So let's create this target rule now. So we have to add a category here. So we're going to add the category of problem. And then we're going to create these 3 dictionaries. So first we want to extract the lowercase CKD, then the lowercase stage, and then anything that's like a number. We're going to add this rule, reprocess our text, and look what it extracts. And now it gets both CKD stage 3 and CKD stage 2. And you could even do more here. So let's just quickly check that it'll work anyway. Let's look at CKD stage 5. All right, that worked. 4. Let's look also, let's see if it'll work with a Roman numeral. So that didn't work. It'll also work with something that's not legitimate, like CKD stage 6, which as far as I know doesn't exist, but that still works. Okay, so let's see. We've gotten most of the concepts that we're interested in. We've got 3 problems, but there's still these 2 other classes of treatments. So RIJ, line placement, and SWAN. So let's extract these and call them treatments. So we'll do this by creating a target rule. Let's say RIJ line placement, call it a treatment, and then for the second one, create a target rule, which is SWAN, and we'll call that treatment. Okay, we add them, process our doc, and let's look if it worked. Okay, so it looks like it did. So now we've processed this entire sentence, and we've gotten all of the entities that we're interested in. Okay, so next, you're going to write some of your own rules to get these texts here. And I'll help you get started, but then I want you to work on it on your own, and then you'll submit this notebook for credit for the week. Okay, so I'll help get started. So let's start with this first sentence. So here we see that 2 names of diseases we have in here are hypertension and end-stage renal disease. So let's create a let's see, did we already do, we had hypotension, but we didn't have HTN. So let's create a rule for HTN, which stands for hypertension. And we'll call that a problem. And then let's create another one for end-stage renal disease. Okay, so let's process all our texts. Oops. Okay, so something else that medspaCy gives us, another visualizer, is this widget. So widgets are used in Jupyter Notebook so that you can interactively interact with what's in the notebook. And so if this cell isn't displaying, if it just doesn't show anything, try running these or looking up documentation for IPy widgets, or you can uncomment this and go through one by one. But basically what this widget will do is, so we see the first one here, we've got problem and end-stage renal disease, both highlighted. And let's click through and see the other examples. So here we're not extracting anything, so we'll have to add something there. Same here, here, and here. Okay, so let's go up and let's add some rules for this sentence. So ABX, that's antibiotics, and so that's going to be a treatment, and infection, that's going to be a problem. So let's add some new rules here. So target rule, so we need ABX as a treatment, and then infection as a treatment. Let's add it, reprocess. Great. Okay, let's see, I'll do one more with you. So let's see, congestive heart failure. Let's do one more. Congestive heart failure. That's a problem. Reprocess. And okay, we should be good. So if this widget isn't working for you, one thing you can do is uncomment this and just go through one by one. So you can see the first example there. Second one, you still need to add a rule for, etc. So when you submit this, there should be at least one entity extracted per sentence. So try going through and seeing what you want to extract, writing these rules. Let me know if you have any problems. When you're done, download this as an HTML and submit on Canvas. And then you can go on either this week or next week to the next notebooks to continue working on this.